Hey everyone, hope you're doing well. Today we're going to be talking about tests. So I got a bit of feedback saying that I should try smile a bit more, so I thought I'd give that a go before we got started. So the majority of engineers hate writing tests, right? It's just a thing. We enjoy designing and thinking about how the code is going to look and the implementation and the abstraction layers. But then at the end we've got that thing, the chore that we have to do, which is write tests. And more often than not, if you're quite unlucky, you'll probably end up refactoring someone else's test because you broke it along the way. So I think I know why we hate testing so much. And it's quite simple. It's because we never really got taught how to do them properly. When I think back at my uni days, or if I think back at qualifications I've done, courses at work, or even YouTube tutorials, most of the focus is on the code or on the implementation, and very little thought is given to how to test them, right? Some of them might have some tests, but I found that most of the time they're quite small, or they don't really give you an idea of how to use them in a practical environment. And I think because of this, we've picked up a habit of writing bad tests, or tests that rely on the implementation. And obviously what this means is that anytime you're updating or refactoring the code, then the tests are going to break. So it becomes a bit of a mess. And I'm no exception to this. I used to always hate tests. They were always a pain and they always got in the way. But more recently, I've been trying to change my mindset towards the tests. I've been doing a bit more research into how to do tests properly. And I think I've been a bit lucky to work with a few experienced guys that have taught me a lot about how to do it right. And now my thought process is revolved around tests. I can't imagine writing code without tests. I'm not saying I love them, but they're definitely making life much easier. So today I'm going to be sharing a few tips that change the way I think about tests, and hopefully they'll make life easier for you. Before we get into that, I think we need to understand why we test in the first place. Now, I think most people understand the main reason for testing, but I think there's a few other reasons that we're missing out. So the main reason, of course, is to catch bugs. We want to ensure that the code that we implement behaves the way we expect it to, right? And this is increasingly important nowadays when you consider where technology is, right? If you think about technology in medical equipment or transportation equipment, one bug can cause huge implications there. So we want to completely avoid that. A second reason is to document the behavior of the code. It's really difficult to read other people's code sometimes, right? People just think differently. That's just the way it is. But if you've got a good set of tests that describe the behavior of the code, that's going to make life a lot simpler. Now we're going to get into this a bit more later on. Another reason is to enable refactoring. I think it's a reasonable thing to say that maybe half the time you spend coding is refactoring or reading other people's code. So imagine every time you're updating code or refactoring someone else's code, you break all the tests. That's not what you want to happen. And this is something else that we'll go into later on. So in general, I think it's important to just remember that tests shouldn't get in your way. If they're a pain or you're spending lots and lots of time on it, then there's probably a problem with the tests. So the last thing you need to remember is if you want to build a good quality product, you need to have good, meaningful tests. Now, the first thing to understand is that there's different levels of testing. Now, this is going to vary depending on the company that you're in. You might have specific services that are very high profile and important to your company, and you might have other ones that are only used internally. You need to understand that the one that's high profile is probably going to need a lot more attention in terms of tests than the internal one. Now, there's a few concepts out there that give you an idea of what levels of testing there are. Now, one of them is the testing pyramid, and I'll pop that somewhere on the screen. Now, take the terminology here with a pinch of salt. There's lots of different examples online and even ones with different levels, but the concept is solid. So at the bottom, you have tests which are very quick to run and they're very quick to write. And as you go up, writing the tests become more expensive and running the tests are a lot slower. So I think unit tests are quite well understood. These essentially test the smaller unit or behavior of the code. And as you step up the ladder, it becomes a bit more brittle and a bit more expensive to write. So you go up to service or integration level and you start bringing in other resources which you then need to take into account. Again, it gets a bit harder. If you go up to the top level with UI or end-to-end testing, this is the most expensive to write, and it's actually the most brittle. So for example, if you're watching this on YouTube and you wanted to test the UI, you might click on some of the videos, the comment section, the like buttons, and you would see if they behave the way you expect them to behave. But then when YouTube changes the layout, all your tests are going to fail all of a sudden. So these kind of tests are much better brought down to the unit level where the UI doesn't matter. Speaking of, feel free to test the like or subscribe button just to make sure they work. But seriously, if you enjoy my content, it would help me out a lot. The next tip is to write the tests before you write the implementation, right? There's a concept for this called test-driven development, or TDD. Now, I think this concept is quite well known in the tech industry, but it's always one that I struggled with. I never understood how you could write a test without understanding the underlying implementation, right? But I was thinking about it in the complete opposite way. The test should have no idea about the implementation. You should be able to write the tests, and anyone should be able to come in with different implementations, and the test should still work. But it's still important to think about the design of the code. So you can think about the tests and the design, and once you understand the inputs and the outputs and the interfaces, and you've written your tests, then you can move on to the implementation. Now, I think writing tests first is something that's very difficult to do. It takes a lot of practice, but once you get into that habit, once you get into that mindset, it becomes a lot easier. So tip number 3 is to look at them as specifications and not tests. Now, this one's a bit of a difficult concept to grasp. So we'll look at an example as well. So what this concept means is instead of writing just what the function does, try to describe the behavior of the function in a way that can kind of clearly be understood. So as an example, if we're implementing the withdraw functionality of a bank account, if we think about the behaviors associated with the withdraw as opposed to just what it does, it makes it a lot more clear to understand what's going on. So a bad example of what you could do is just write a test that says, should withdraw or something along those lines, right? It doesn't quite describe what it's doing. We may understand because we have an expectation of what it should do, but the tests don't quite describe it. So here are some examples that essentially describe the behavior of what we'd expect to see. Now, a lot of the time you might not even need to think of them yourself. If you've got a product team or a business analyst working with you and they're writing the stories for the features that you need to implement, they'll probably provide you with acceptance criteria or requirements to complete that ticket. And most of the time they could just be lifted and converted to these specifications. And just to reiterate, the reason it's so important to write specifications like these is that if somebody else comes in and refactors or updates the code and these tests still pass, you can essentially guarantee that the behavior you expect is correct. So tip number 4 is to make tests readable, right? So this is super important. People are going to be reading your tests, people are going to be reading your code and trying to understand it, so make the test readable. One thing you can do for this is highlight what's important and hide what's not. So essentially what this means is if you have a bunch of setup or variables that aren't really important to the test, take them out into a method and give the method a meaningful name. And if you've got something that's very important, maybe highlight it with a variable name. So we can have a quick look at an example of this. Straight away we can see the difference in the test names. So the good test is gives you much more context. It's much more clear what behavior it's trying to describe. The bad test not so much. And then when we look into the implementation, we can see in the bad test that there's a few variables that are needed to create the user that aren't really important for this test, right? So we've got the number 10, the 2 empty strings, the number 14. It's not really clear what's needed here and what's not. So in the good test, we've extracted out the variables that we don't really care about into a method, and we've highlighted the important one, which is the age, and we've explicitly popped that in. So this is just one example of a simple test. I'm hoping that you can imagine how much this will help if you have kind of huge tests that require a lot of setup or a lot of initialization. So tip number 5 is around testing edge cases. So up to now, we've mainly focused on essentially business requirements. But the honest truth is most of the time, it's the code that lets us down, right? Pieces of code are typically reusable, so they might be used by other services or other applications. So essentially you want to make sure that the inputs and outputs are what you expect them to be. So as a rule of thumb, you can follow the 0, 1, and many rule. So again, all to do with inputs, try it with 0, try it with 1, try it with many. That will handle the majority of the test cases. Test the boundaries. If there's minimum or maximum values that you can do, chuck them in. And also if you're dealing with collections, do empty collections, try passing nulls. These are all essentially edge cases that will make your code a bit more foolproof. I wouldn't spend too much time on this, but I definitely think it's important to make sure that your code can essentially cover cases that it might not expect. So if you want to look into any more of the tips that I've talked about today, I've added a few links in the description that essentially are the resources that I use to help me make this video. So I'd recommend checking them out. Let me know in the comments below if you tried them out or if they helped you at all. And thanks for watching. See you in the next one.